All right. I'm going to try and record my lectures this semester. I haven't ever done that before. If you want to tune in to my Zoom session, you can do that. I cannot minimize Zoom. Okay, fine. All right, let's time for your welcome speech. Welcome to CSC 1351. It is a journey into this and this, right? So it's not too late to save your grade for most of you. But for some of you, maybe. What am I talking about? Many of you didn't learn what you needed to learn last year for whatever reason. You fooled yourself into thinking copying answers is learning or letting the IDE do things for you is learning. But if you don't have understanding, it's not going to work. If you are a person who doesn't write programs unless you're forced to by your class, you may be in trouble. You may even be in the wrong place, right? Because if you want to be a programmer, you should like it. You should do it when you're not forced to, right? It should be kind of like a computer game to you. So as of this moment, you should start thinking, hey, maybe I need to change my ways. I say this because my experience is that about half of the people sitting in this room will not pass, right? And it's not, I don't want it to be that way. Like a quarter of you will drop, you'll realize it's too hard and you'll drop. A quarter of you will stay the course and just won't make it. I will do everything I can to help you, but that's my experience of what happens. So I just want you to be warned. There will be lots of quizzes in this course. I aim for getting at least 12. I don't announce when it is. It's just whenever you come in someday, you might see a stack of bubble sheets there. You have a final project, which is 1,000 lines of code, and I'll give you more instructions about that, but you have to use a package called Basic Graphics that I wrote. If you don't do that, you get 0 credit. This class is hard. Sorry. You can't get through this class by using AI and getting answers from your friends. What I'm trying to do is I'm trying to get you young recruits into shape. So there's some good news, right? We have some smiles too. So I've scared you a little bit, I hope. Now we have some smiles. So we have a syllabus that tells you what we will be doing on every single day of class and every lab. And you can look at it right now. If you go to the class website. Oh, by the way, if you go to Moodle, there's a Moodle for this class. And the only thing that's really in it is a link to the website I use with all the information on it. And on that website is a link to the syllabus. Also in Moodle, there's a link to the syllabus. And you can click on the days. And when you click on the days, it shows you what's going on the day. Your grades are always going to be up to date. I know many of you have been in courses where you get to the, you're almost at the end of class and nothing's been put into Moodle and you don't know if you're passing or not. That's not going to happen here, right? I'm going to try to keep you up to date on the trajectory that you are in this course. So based on what you have your grades for everything. I will probably learn most of your names because I'm always open to questions. You have any questions now? Okay, nobody has any questions right now, but I'm going to get you to talk to me. All right. So I encourage questions. There are labs, there's a final project, but there's no homework. Yay. I've come to think that homework is useless. I've assigned it in the past. People just go get the answers from somewhere and they turn it in. And I see people get perfect 100% on homeworks and get 0% on quizzes and tests. And I think, what's the point of this? So I don't do homework, but yay. You still have the labs though, and we'll talk about that. Labs, I will be present at labs. I assume that's a new experience for most of you to have your instructor present at labs. So I will be there, and I will be, it's kind of like a bonus office hour, if you will. If you come to labs with any problem, we can try to address it there. I do not take attendance, but note above, there can be quizzes at any time, right? So if you don't come to class and you miss a quiz, that's a 0. So you probably don't want to miss class. Any questions to this point? Yes. What's your name? They're going to be paper tests. They're going to be bubble sheets. Everything will be in some flavor of multiple choice, because otherwise I would spend every waking moment of my life grading you. So, all right. So I tell this to students every year, and hopefully some of you listen. You must write programs every day. You must understand Java syntax. You can't just let the IDE just do everything for you. You have to know what it's doing. You can't just look at a page of code and intuit it. That's not good enough. You have to understand Java grammar, what things go before what other things, what they mean, what order they're in. You must understand, for example, the scopes of variables. You must test everything you think you know, right? You should write a program. If you think you understand something, that the code does, you write a program for yourself to test it, right? And if you write programs for yourself to test whether you understand something and see if you can make the compiler do things, the language do things you want to do, that is the best way to learn. It is by far the best way to learn. If you do that, you will pass this course. If you don't do these things, you probably won't, okay? Let me just spend a moment more on writing programs every day. So some of you don't currently do this. I'm not going to try to figure out how many, but you need to start, and probably today. Now, what I like to say to people is start small, take baby steps, right? You can't just change your life overnight. It's not something humans can do, right? So what you do is you pick a time, 15 minutes, you're going to sit and work on code. And you can set a timer for yourself to know that when you've done at least 15 minutes, but you could do more. But set a timer for yourself every single day and spend 15 minutes trying to work on code. If you don't do any coding currently, do that. And if you can do that, that will help you enormously. Doing that alone might help you to pass this course. And I have a book recommendation in addition to the course book, which is kind of a recommendation because I don't follow it particularly closely, but there's lots of good information in there. I have another sort of recommendation that's not a course book at all. It's called Atomic Habits, and it's about how to build habits, how to take control of your body, how to program your own mind, right? Because right now, most of you have habits that you've never thought about. They're just habits that you built by accident, by what you wanted to eat that morning or whatever. So what this book encourages you to do is sort of take control of your habit forming process and build habits that are going to lead you to success rather than habits that are going to lead you to a high score in a computer game and some extra weight, which is what most of our habits will do if we don't take control of them. Any questions? All right. What is a programmer? A programmer is a detail-oriented thinker, not a big picture thinker. I mean, yes, there is room for big picture thinking also, but you have to be detail-oriented. You have to look at every single dot and minus and plus sign and every letter in the program. A programmer does not trust your intuition. I'm not trying to train you to build an intuition which you can trust. I'm trying to train you to realize you can't ever trust your intuition. It's always going to mislead you. A programmer should not trust their book or their professor. We make mistakes. I teach a course in parallel programming, and the book is kind of great because I think I don't know that it's mathematically 100%, but I think every single program in the book has an error in it. Some of them are really terrible errors. Some of them are minor errors, but I think every single one does. And so I make mistakes too. I'm going to say things wrong. They'll just come out of my mouth wrong for whatever reason, just because I'm a human being just like you. So a programmer tests everything. You don't just take somebody's word for it. You don't take the book's word for it. You test it. You're a mechanic for electrons. In this course, we're going to take things apart. We're going to take standard utilities that you use every day. We're going to take them apart, show how they work. We're going to put them back together, figure out how we built them. A programmer does not passively learn. If you just sort of sit there, right, and take it, that's not the way to go. There's like these fish. They put up atomic nuclear plants, and they have these. They have to bring water in and water out to cool them, and the fish would come up and they would latch onto the outgoing grate and they would open their gills and let the thing breathe for them. And then when they turn it off, the fish die, right? Because they've lost the strength to breathe or whatever. I heard this somewhere. You shouldn't trust me. It may not be true. Okay, so the final project. There will be 4 steps to the final project. I break it up into 4 steps because I know that if I don't do this, many of you will not have the discipline to get started when you need to. Many of you will not pay attention to the instructions on how to do the final project, and so maybe your first time that you turn something in, it will be something that's completely wrong. The requirements for the final project are spelled out in detail on the course website. Please read it. This is the course website, and this is that wonderful syllabus that shows you what we're doing every single day. Life lesson: your grades don't matter. And I know this is something that, like, you're a student, so you're focused on the grade. The grade is the barrier that I must get through. The grade is my hurdle. I can only see the grade. What can I do to get past the grade? The grade doesn't matter. Before I worked here, one of the places I worked was my job to interview students who came in. It was my job to interview students who wanted to work at the company I was at. It was called True Position. And I would get this resume. I remember getting this resume. There's a student from computer science from Drexel University. He had a 4.0 average. He said his expertise was Java, C++, Perl. That was a popular language at the time. And I looked at this resume, and I knew because I saw that 4.0. I knew that it was going to go badly. I knew he didn't know anything. But I waited until I got to the interview, and I asked him questions, and he failed every single one of them because he didn't know a thing about programming. Nothing. Absolutely nothing. And he had a 4.0. Because what I've learned is, over the years, there's some 4.0 students who are really smart. But usually, if you never got a B, if you never got a C, it means that you figured out how to game the system in some way that I don't understand and get through without learning anything. And that's what happened to this kid. And I'm sure he never got a job working in any kind of computer science or any kind of programming field because he doesn't know how. He somehow got a perfect 4.0 average and never learned anything. So what I'm saying is, try not to stress too much. Yes, I understand there are thresholds. You lose your tops, you get kicked out of school, those kind of things. And those kind of things do matter, of course. But focusing on your grade gives you the wrong mindset. You need to learn the material, right? That's what matters. And in this course, if you fail, it may help you, right? Because if you get to the end of this course and you don't understand the material I'm trying to teach you, it's not going to help you to move on to the next course because you're not going to understand that either, right? And so some of you are going to fail. Some of you need to fail. Some of you are in the wrong place. This isn't really what you want to do. You're still figuring out life, and this isn't your way. And I can respect that. But what I'm going to try to do is be a gatekeeper. I'm going to try to say, hey, if this isn't for you, if this isn't something you can or are willing to understand, then I would like you to stop wasting your time and money on something that's going to lead you nowhere. Okay, so I'm trying to help you by grading you the way I do. Any questions? Okay. So the moral is the primary value of a grade is what it tells you about yourself. But I think you don't need the grade for that. I think you know in your own head when you're understanding things. So habits, as I said, we need to make good habits. 15 minutes is what I encourage you to do if you're doing nothing, because it's hard to get yourself started on a new habit. The important thing is consistency. There's a lot of other tricks to it. Atomic Habits is a book that might help you with that, if you want to take a look at that. I always like to keep a drink because you're talking for a long time and your throat can get scratchy. Okay, responsibilities. Read your email. I'm going to be sending email out from the Moodle website at various times. You need to keep up to date with it. We are not, you're going to send me email and I'm going to fall behind because there are, what, 90 of you, and there's only one of me, and things are just going to get lost. I'm going to do my best to keep up with these things, but try and be patient with me. If you really need me, the best place is my office hour or lab, right? Because the electronic forms, I do catch up. I do try to keep up, but it's hard. Watch Moodle. I'm going to be putting things there. Look at the course website. You need to read that over. It's just really one page. You just have to go through it. Come to class. As I said, there will be quizzes. If you, my experience is students who don't come to class don't pass, right? There are some students who just won't come to class. They won't show up at lab. But you know what? The most brilliant students, I find, the ones that really know what they're doing and the ones that pass, they show up to everything, right? That when I have a lab, they don't figure, oh, I know it, I can do it without the professor. They show up. All right. There is a Discord. There's an invite to it on the website. Read the text, practice, practice, practice. Programming is a skill. So if I were to take any of you and say, if this was a course in basketball, right? And I was going to teach you, okay, how to throw a basketball, how to get it in a hoop, and if I taught you, the way you should stand with one foot, like whatever, and hold the ball, whatever, and we did all that. I lectured to you on that, and you took a written test on, you passed it. Do you think you would be a good basketball player? No, you wouldn't be able to do anything. The same thing is actually true about programming. If you just listen to me talk and you don't program yourself, you're going to be like a kid who went to school to sit in a classroom to learn how to play basketball. You won't really learn it. So don't think of programming as being like a sport, like basketball. If you don't do it, you won't be able to do it. So I can't just impart the knowledge into your brain and have you be programmers. You have to get out on the court. Okay. So just encouraging you to look at every detail of every line of code and make sure you understand it. Don't just gloss over things, right? Make sure you know exactly what everything means in your program. If there's something in your program that seems like magic to you and you just do it, don't let that be the case. Talk to me about it. Ask me what it is and why it's there, okay? If you just sort of skip all that and you daydream through class and you don't pay attention, you're probably not going to pass, and we don't want that. Okay, so hopefully you have a mixture of fear and hope and some kind of excitement, and good luck. Let's have fun. So that's my motivational part of the speech, or demotivational part, as you will. Any questions? Yes. I don't know. I just work here. What's your name, by the way? Scott. So I was a surprise to me when I got to 1100 this morning and they said we were going to be here. So I'm in the same boat you are with regard to that. I don't know why we weren't told. They've told us in the past when they've closed classrooms. I don't have that, but anyway, I don't know. I wish I did. Let's take just a minute to look at the website itself. So this is what it looks like. This gives you the breakdown of the grading. I'm going to try to keep that up to date. This is when we have our final exam, 7:30 in the morning. Doesn't that suck? Okay. Academic integrity. So cheating will not be tolerated. LSU code governs all work. For labs, you're expected to try and do the lab without help. But I know that many of you can't, right? I don't want you to take a lab, to come and get to lab and sit there and stare at the screen for the whole time and not ask any questions and then, get a 0. The labs are expected to help your grades, not hurt them. So when you come to lab and you're stuck, get help. All right. I'm going to be there. Hopefully we'll have a TA there. Come to the labs, get help. Sometimes you can help each other while you're there, right? I'm not opposed to that. It's not the same as a test. The point of the lab is I'm giving you a small exercise and I want you to understand all of it. And what you should do is you should work on that lab until you understand everything. And then you can turn it in, right? But please come. As I say, those people, my experience is people who don't come to the lab often don't pass. For quizzes and tests, no copying is permitted. I have 5 versions of every quiz and test, so it's always hard to do that. There are no notes, calculators, computers, tablets, phones, devices of any kind. Please visit the bathroom first, not during. If you have to visit the bathroom, please surrender your phone while you're out. There are no makeups for exams. The exams are given at one time. Everybody gets the exam at the same time. If you can't make it for some reason, I will excuse you, but I will not let you take it at a different time. Deviation from these guidelines can result in punishments by various means. All right. All my slides are available on this webpage. There are links to it. The ones I just went are right there. My office is 2004 DMC. My office hours are going to be every Monday from 12:30 a.m. Huh? Well, no, p.m. I'm not getting here at midnight. TA office hours, I don't know yet. This is the Zoom link in case you want to do Zoom. This is the ZY books, which is recommended reading. This is a calendar to try and find office hours if they're not available. There's supposedly the classroom. It's not, at least not for now. Our lab time is 1:30 to 4:20. I'll post the lab room. I haven't got that on here yet. There's my email. All the slides. When I do examples from class, sometimes live examples, I will post them to this examples link. Then we have the final project. We want 1,000 lines of code. We won't count it if it's a comment, a blank, a line with a single curly brace, it's an import, repetitious code, etc. And there's a tool now to check your line counts. And the grader may decide to reduce the line count for repetitious code or other reasons. Like sometimes I get a project turned in with a bunch of random classes that aren't used at all by the final project, hoping that nobody notices, right? So those kind of things won't be counted. All right. And this is at the bottom is the basic graphics thing that I told you that you have to base your final project on. Here is the syllabus/schedule. It shows you every day what we're doing. So we have no lab this first week. Yay. All right. Any questions? Yes. Your name is? Ding. Okay. Oh, it's a holiday. It's all color coded too. So, all right. A bit about me. I work at the Center for Computation and Technology, which is in the Digital Media Center. My title is Assistant Director of Computational Science. In my research, I work on a coding framework for simulating black holes and neutron stars. It doesn't use Java, but I like Java. Java is kind of a nice language in that it's not particularly complicated, but it has a strong typing system. So it kind of strikes a nice balance, but Java has a lot of problems as well, and we're going to get into some of those details. Okay, with that segue, we've got what, 20-minute or official end of class is 10:20, is that correct? So we've got some time. So let's go on to lecture 0. So we're going to talk about basics. Some of this will be a review, but I do expect you to review things on your own. As I said, this is like learning basketball, so I can only do so much for you. These slides are probably not self-contained, and it's not exhaustive, but it's going to hopefully give you get you on the right track. So here is Hello World. Should have been the very first thing you learned last year. You have a program that every program has a public class. It has a name. Class names should begin with capital letters. They aren't required to by the language, but it is expected that's what you're supposed to do. Every class that is an executable that you can run is going to have public static void main string array args. You probably don't know what all that means as yet. By the end of this class, you will. Then you have system.out.println hello world, and that's going to cause the words hello world to appear on the screen. Generally speaking, anytime you want to learn a programming language, the first thing you have to do is learn how to write hello world. And so that's what you had to do. Now, you very often, when somebody claims to know a language, they come into my office for an interview or something, they claim that they know a language. I ask them if they can write hello world in that language. And it's very rare that anyone can. I don't know why. I can write hello world in all the languages I've learned, but I don't know what it is that people think they can claim an expertise in something and they can't do that. Okay, basic concepts. So in Java, there are types, and types are, containers for data that have various flavors. And it's important that we understand what they are and how they work. So types are divided into two types. There's primitive types and there's objects. There are 8 primitive types. You are expected to know and memorize the list of primitive types, and that's given to you up here. Now, the thing about primitive types is that they are assigned and passed by value. Okay, so we'll talk about what that means in a bit. You can compare them with the equal operator. They may not be null. Primitive types can never be null, right? They all have wrapper types, which are objects, and these are and over here I have the list of the wrapper types as well. Now objects are passed and assigned by reference, and they're compared with dot equals instead of equal, and they may be null. Any object can be null, and all objects, at least in the machine code, are allocated with operator new. So there are kind of some exceptions to this allocated with operator new as far as your perspective on the code goes. So if I wrote quote hello quote unquote, right, that is a string. A string is an object, and when you did that quote hello unquote, you were implicitly calling operator new, although you didn't know it. So sometimes the call to operator new will be implicit, but if there's but most objects require operator new, and if there is a new, then it is an object. Is there any question on this? All right. Okay, so passing by value. So let's take a look at this program. We have a program called foo1. It's got a method called static void foo. It takes an int n argument. I have my public static void main, which I must have to execute a program. I declare a variable named x, and I initialize it to 3. Then I call foo with 3, and then I print that variable out. That variable is still going to be 3. Now, why is that? Does anybody know? Does that surprise anyone? Yes. What's your name? Lucian. Yes. Right. Right. So what Lucian said is correct. Because they're passed by value, right? What I've done is I've passed the number 3 to the foo function. The number 3 is always going to be the number 3, right? I can't change the number 3 to be the number 4. Now I can change a memory location to hold a 4 instead of a 3, but that's not what passing by value means. I'm not passing a memory location. I'm passing the actual number 3. Okay, so what happens with foo is when it says that int n, it's declaring a new memory location and it's storing the 3 in there, right? N++, who knows what that is? JJ? Right. So that's what it's going to do. It's going to increase the value of the memory location by 1. So this n is now going to have a 4 in it, but that has no impact on the calling function, which is main. Does this make sense to everybody? Good. Again, this is stuff I hope you already know. I once asked if I could teach 1350 because I was thinking it would be nice if I could, I could groom people from the beginning and then I could alternate. The computer science department said no. All right. So I'll just take what I get. Here's public class foo2. We have another static void foo, and this time instead of having an integer as the argument to the function, we have an integer array. And I am incrementing the first element of the integer array. And what I am doing inside main is I'm allocating an integer array. If you know that syntax, what I'm doing is I'm creating an array of size 1, and I'm putting in the index 0 position, I'm putting a 3. And then I'm calling foo with that x operator, and then I'm doing a system.out.println of x square bracket 0. And now I'm going to get 4. Does that make sense? So what happens is an array is always an object. An object is passed by reference. And so when I pass that x function to method foo, what is not the array itself is not really what's passed. What's passed is the memory address of that array. So it's just a pointer to the location in memory where that number is stored. And so when I increment the number at that address, it's seen by the calling program. Okay, so that's the difference between passing by value and passing by reference. And it's very important that you understand that, or you can't really make any progress with anything. Any questions on that? All right, you will be getting quiz questions and so on to verify that you understand this concept. Bless you. Okay. I always like this program. This program is so great because it kind of blows your mind the first time you see it. So what I have, right, is I have two declarations. Well, I have 2 pairs of declarations. I have integer, capital integer, which is an object, and I set that to A1, the A1 equal to 3 and A2 equal to 3. Now, when I have a wrapper type for a primitive type like integer, which is an object, Java implicitly does this thing called auto boxing. It converts that primitive type into an object type for me behind the scenes without my seeing it. It goes back and forth that way. And then on the next line, I'm taking 2 primitive types, B1 and B2, and I'm setting them to 5. Now, the next 2 lines, I'm comparing the 2 things with equal. And surprise, surprise, they're both equal, right? Because I initialized them to the same things, right? So they should be equal. There's nothing surprising about that. Now what I'm going to do is I'm going to increment them both by 124. And then I'm going to print A1 and A1 equal A2. And it's still equal, right? I mean, I incremented by the same thing, right? Now I'm going to increment A1 and A2 one more time. And now I get false, right? Both of these, both A1 and A2 are equal to what? 124 plus 3 is 127 plus 1 is 128. They're both equal to 128. And when I compare them with equal, I'm getting a false. Does that blow your mind? People who are paying attention are nodding their heads. Okay, this should be kind of blowing your mind because you're thinking, what the heck? So remember when I told you one of the differences between primitive types and objects? Primitive types are compared with what? Equal. What are objects compared with? Dot equals, all right? What are A1 and A2? Are they objects or are they primitive types? They're objects. How do we compare them with equal equal? This is why, because stuff like this can happen. So what happens is when you compare objects with equal equal, it doesn't compare the value of the object, even if it's a primitive type. What it compares is the machine address where the object is stored. And why does that only happen with 128? Well, because Java is doing magic things, right? And what they do is when they do this auto boxing, this conversion between integers, int and integer, when they're doing this conversion between int and integer, what they have is they have an array of 128 objects, 0 to 127. And if that integer falls in the array, it just returns that object from the array. But if it's outside of that array, it has to allocate a new one. So what happens is up until here, it's getting the values out of the table and returning them to you. And so when you compare the address in memory, it's the same address in memory. But once you get to this one, okay, it's no longer coming from the table. It's allocating a fresh one for every time you do it. And now they're different locations in memory, and equal equal fails because equal equal isn't doing what your intuition tells you it's doing, right? It's comparing the address in memory. And so this is the thing I dislike most about Java. This drives me nuts. I really wish they didn't do this, but that's the way it is. And you have to know about it, because if you don't know about it, someday it will bite you and you'll be totally baffled, because you'll be comparing these things and they'll be working fine until you get outside of the 0 to 127 boundary. Yes. Yes. So this will work for integers if I'm always in the range of 0 to 127. But as soon as I go outside, it fails. And that can be very mysterious when it happens. I have spent hours debugging something because of this. All right. So that's a thing that you need to understand. And any questions on that? All right. Okay. So here's another code example for you. It's called strcomp. And what we're going to do is we're going to compare two strings to see if they're equal. So first thing I'm going to do is I'm going to create string A1, which is hello world. And then I'm going to take string A2, which is just hello, and then I'm going to append the world string onto there with a plus equal operator, right? You're familiar with the plus equal, right? Okay, so I'm going to append it on there with the plus equal operator. And then I'm going to print out whether they're equal. And they won't be, of course, because what's happening is we're not comparing by value. We're comparing machine address in memory where the object is stored. And we have two separate addresses in memory where hello world is now stored. So those don't, so we get a false there. However, if we call equals, this equals method with A1 and A2, that's going to work. But there's an unfortunate gotcha to comparing with. So normally I would use dot equals, right? I would say A1 dot equals A2. But there's another unfortunate gotcha, and that is all objects can be null. And if I say A1 dot equals A2 and A1 happens to be null, then I've got a problem, right? So what I usually do is at some point when I'm making any Java project is I make for myself a static Boolean equals method that takes two objects. If A is equal to B, I return true. If A is equal to null or B is equal to null, I return false. And then finally, I call A dot equals B. So how does this work? So we have to walk through four different cases, right? So first case, A is null and B is null. Both of them are null. Okay. Will this method work? Well, the first if statement, if A equal B, returns true if both are nulls. So that's good, right? Two nulls are equal to nulls. We're happy with that. Also, if I've got two strings that just happen to be the same address in memory, they're going to be equal. That's going to be handled. Now, let's say that A is null and B isn't null, right? So if A is null and B isn't null, then I'm going to return a false right here. And likewise, if B is null and A isn't null, I will also return a false here. So if one of those two things is false, I bomb out. I bomb out with a false, and that's good. And then only if I get past those two things do I say A dot equals B. And at this point, I know that A isn't null. And if I pass a null to the dot equals method, I won't cause any trouble either. So if I use this method, I know that I can compare things for equality in a safe way. And that seems like more work than I should need to do to compare whether two things are equal, but that's the way it is. Any questions? So this is a kind of thing that I will test you on, right? I will give you various versions of this equals method, and you'll have to think it through. You'll have to think, what happens if A is null and B isn't? What happens if A and B are both null? What happens if B is null and A isn't? What happens if neither of them is null, right? So I want you to be able to think through that logic step by step. And when you look at a program, you shouldn't just look at a program and say, my intuition says it does this, right? You should follow it step by step. You put it, on the side here, you wrote A is null, B is not null. You go, if A equal B, no, that doesn't happen. And then you get to this one and you check it and say, oh yes, it exits, right? And then you make a table of all four of those cases I described on your notes or in pencil or in your head or somehow. You have to be methodical, right? And you have to pay attention to the details. All right. Are we having fun yet? Cool. I kind of feel like feeling like the fun begins with this program. This because it blows your mind and you can show your friends and blow their minds. Yes. What's your name? Kobe. Which one? This one? Well, A1 and A. So okay, so this is showing you generically what you should. Yeah, this is generically. And for this particular example, I could have said A1 dot equals and it would have been fine. And I'm probably going to have to ask your names multiple times. Sometimes I'll get it, and then the weekend will hit, and over the weekend I'll forget some. But I'm going to keep working at it. I can't learn everybody's name because there's just too many of you. But the ones who ask questions regularly, I'll probably get you. Okay. All right. Plus plus and minus minus. So plus plus and minus minus are really cool because adding one to things or subtracting one from things is something that you do a lot, and it's a nice shorthand. And it's kind of intuitive, I feel, for your brain to say plus plus is to make it one bigger. And the C programming language, when they wanted to make a more powerful version of it, they said C++ because if you understood the plus plus increments things, it was like a cool, nerdy thing. Okay. But there's a little bit of a subtlety to plus plus that I want you to appreciate. Okay. And that is the plus plus can go either before or after. So it can be a postfix or it can be a prefix. Okay. If it's a postfix, it's going to return the original value. So if A is 1, then A++, when I print that out, that first line is going to print a 1, not a 2. But after that line prints out, A will have a 2 in it. Okay. So if I print it out on the next line, when I print out A, I see a 2, right? So A++ means increment the value, but return the old value. Okay. And if I do a plus plus in the front, if I do the plus plus, this is like you're thinking you're doing the plus plus part first or the plus plus part second, is the way you can think of it. If I put the plus plus first, then it increments it and returns the new value instead of the old value. And so I get 3 and 3 for both of the last two. All right. And the minus minus operator works, the prefix and postfix of the minus minus operator works the same way. Does that make sense? I kind of think that you should have all known this, but my experience is that you don't. So, and you will probably get a quiz question on this. Arrays and array lists. So the manipulation of arrays should be familiar to you. I find that it's rarely something people have any knowledge of when they get here. We're gonna therefore do an example. I don't know. I'm gonna have to go through this pretty briefly, given that we're almost out of time. But here is a program, and the purpose of this program is to remove even numbers from an array. And when I do a program for manipulating an array, it always has a pattern to it, right? So the first thing I'm going to do is because arrays are immutable, have an immutable length, I can't make them bigger or smaller. I have to figure out, first thing is how big is the array that I want to return. So what I'm going to do is I'm going to go through this array and I'm going to calculate the number of odd numbers in it. Okay, the second step is I'm going to allocate my return array, which is going to be equal to the number of odds. And then my third step, I'm going to copy the values into the array that I want, and then I'm return it in the fourth step. And that's basically the pattern they all follow. The percent operation is the modulus. So %2 equal 1 is going to tell you that you have an odd number. What do you all think of this program? Who has a question? Somebody has a question. If I gave you a quiz on this particular thing and asked you to remove every third number, could you do it? Okay, well then you have a question. Try and think of it. Sometimes it's okay for the question to be, when you went too fast, do it again slower. I had a student who did that to me last semester all the time. All right. Any kind of question is okay. I'm not grading you on the questions, right? So, and you don't have to worry about looking stupid because no one's, yes. What's your name? Serene, yes. Oh, result n++, because what I'm doing, right? So I have to keep track of two positions, right? So first, the position in the array that I originally was given, and then in the array that I'm filling in, right? So the idea is I start with an n equals 0 here, and every time I put a value into this array, I'm incrementing the position where I put so I can put the next one in the right place. So the I and the n are progressing through different arrays at a different speed. Make sense? It was very good Serene asked that question because there was like 100 other people in here, even though there aren't 100 people in this room. There were 100 other people in here who were wondering that same thing. Okay? Does this all make sense? I would, if you're going to go home and do your 15 minutes of programming, try and focus on this one. See if you can fully understand this one and come up with all kind of variations on it. Say, I want to remove every odd number and the number that follows it, or weird things like that. Try and come up with weird ways to say, I want this little piece of an array, or every time I see a prime number, I want to see the square of it on the next element. Come up with things like that for yourself and see if you can do it, and see if you can pair up and give yourself challenges. That would be ideal. All right. Thanks for your attention. Write programs every day.